Assalamu alaikum dear students, welcome to third class of algebraic expression. This is Mohammad Shakar. In my previous class I have discussed about remainder theorem, factor theorem. Today in this class I am going to discuss about converse of factor theorem and problems related to this theorem. Let's join with me. Converse of factor theorem. If x minus a is a factor of the polynomial p of x, then p of a equal to 0. Factor theorem was if p of a equal to 0, then x minus a is a factor of the polynomial p of x. Here converse, so name of this theorem is converse of factor theorem. Okay. Now proof. Since x minus a is a factor of p of x, that means then x minus a can divide p of x. From division algorithm, we can write p of x. Here p of x is dividend. Here p of x is dividend equal to divisor into quotient plus remainder, but here x minus a is a factor. Divisor can divide p of x, so factor is remainder is 0. Okay, and x minus a can divide p of x, so p of x is a polynomial and x minus a also a polynomial, and x minus a can divide p of x, then quotient will also be a polynomial. Okay, so there exists a polynomial q of x such that p of x equal to, that means dividend equal to divisor into quotient. Okay, clear? Here remainder is 0 because here x minus a is a factor. Now putting x equal to a, that means a in place of x, then you get p of a minus a, and q of a. Okay, and a minus a is equal to 0, and 0 into q of a equal to 0. Okay, that means p of a equal to 0. Clear? So our proof is complete now. Example 11. Suppose p of x equal to, given that ax cube plus bx square plus cx plus d is a polynomial with integer coefficient. Your coefficient a is integer and a not equal to 0, and also d not equal to 0, and d also integer. Suppose x minus r is a factor of p of x, then you have to show that if r is an integer, r will be factor of the constant term. That means r also factor of this d. Okay. Okay. Now proof. From converse of factor theorem, we get p of r equal to 0 and p of r equal to, replace r in place of x. Then we get ar cube plus ar cube plus br square plus cr plus d equal to 0. Now taking r as a common from here, then you get ar square plus br plus c into r equal to minus d. D changes side, so minus d. Since r is an integer and a also integer and coefficients are also integer, so this term ar square plus br plus c also integer, this term also integer, and r also integer. So, and product of two integers also integers, and d are also integer, and this product of these two equal to minus d. So here this and the r are factor of d. Clear? We put out this 2 and get r. We put out this 2 integer and get r. So obviously r is a factor of d. Okay. So first proof is complete now. First proof is complete. And secondly, if r of the form p by q is a rational number, here if r is an integer, then r will be this factor of d, and if r is a fraction and rational number, and R is of the form P by Q, and P by Q is reduced from, that means here P and Q are co-prime. Reduced from means if we divide 2 by 4, then reduced from of 2 by 4 equal to 1 by 2. 1 by 2. Okay, this is the reduced form of 2 by 4. Clear? So here 1 and 2 are co-prime. If R is of the form P by Q and P by Q is reduced from, then P Q co-prime. That means P cannot divide Q and Q cannot divide P. Clear? Okay. Now from converse of factor theorem, we get P of R equal to 0 and P of R equal to this, and R is of the form P by Q. So putting P by Q in plus of R, we get this, and calculating this, we get Q cube denominator, here Q square denominator, here Q denominator, and LCM Q cube, and multiplying both sides by Q cube, then we get this AP cube plus BP square cube plus C PQ square plus DQ cube. From here we change sign DQ cube, then you get DQ cube, then you get this. Change side DQ cube, then you get this, and taking P as a common. From here P and this are integer of the form P by Q, and P, we know P are rational. In case of rational, PQ are also integer. So these two are integer. These two are integer. So AP square plus BPQ plus CQ square. This expression and P are factor of DQ cube. Clear? P does not divide Q because PQ are co-prime from its reduced form. So P divides D. So P is a factor of D. Okay. So half proof is complete. Numerator is a factor of P is a factor of D. Now, secondly, from this you can also write. If we change side AP cube, then you get this equal to this, and taking Q as a common, then you get this, and this two is factor of AP cube, and Q does not divides P, so Q divides A, so Q is a factor of A. So our proof is complete now. Q will be a factor of A. Okay, clear? Now problem of exercise, problem 5. If a factor of polynomial x to the power 4 minus 5x cube plus 7x square minus a is x minus 2, then show that a equal to 4. We have to show that a equal to 4. Solution: let f of x equal to this, and x minus 2 is a factor of this. So from converse of factor theorem, we can write x minus, from converse of factor theorem we write f of 2 equal to 0. Okay, so putting 2 in place of x, you get 2 to the power 4 plus minus 5 2 cube plus 7 2 square minus a equal to 0. Now solving this, you get a equal to 4. Clear? Now question 6. Suppose p of x equal to ax to the power 5 plus bx to the power 4 plus cx cube plus cx square plus vx plus a, where a, b, c are constant and a not equal to 0. That means leading coefficient is not equal to 0. So that if x minus r is a factor of p of x, if x minus r is a factor of p of x, then another factor of p of x will be rx minus 1. Solution: given that p of x equal to this, and if x minus r is a factor of p of x, then p of r equal to 0 from converse of factor theorem. Okay. Now putting p of r in place of x, you get r to the power 5 plus br to the power 4 plus cr cube plus cr square plus br plus a equal to 0. Okay. Now dividing both sides by r, we get r to the power 5. Now dividing both sides by r to the power 5, we get this. Now partial fraction. If we divide a to the power 5 by r to the power 5, then we get a plus b r to the power 4 by r to the power 5, then b by r plus cr to the power cr cube by r to the power 5, then we get c by r square plus cr square by r to the power 5, then we get c by r cube plus br by r to the power 5, then we get b by r to the power 4 plus a by r to the power 5. Okay. Actually, this is the value of p of 1 by r. If we place 1 by r in place of x, then we get a by r to the power 5, b by r to the power 4, c by r cube, c by r square, b by r, and plus a. Okay. So this is actually p of 1 by r equal to 0. And from factor theorem, if p of a equal to 0, then x minus a is a factor of p of x. Okay. When x equal to 1 by r, or cross multiplying rx equal to 1, then p of x equal to 0. Then factor theorem, you can say that rx minus 1 is a factor of p of x. It's short. This is all for today. Now open your book at page 51. There is the activity chart, and solve activity 1 to 7 and submit in your group within a week. Thank you.